have done this radius of convergence. Okay, so Premraj has asked one question, so just I am telling that there is one method. This is the basic method of finding the radius of convergence. Okay, but sometime what happen in some cases we are not able to find out the nth term easily. Okay, so that's why I will tell you one another method. In that case you can go as per that method also. So this method is complete. So in addition to that, I will write just one line, and with that method also you can find out the radius of convergence. In many cases you will find that easily you can find the Taylor series, and nth term also you can easily find. But what happen in some Taylor series now, the terms which are coming, they are not in some order, or they are not we are not getting clue that how we can find out the nth term. So once we are not able to find the nth term, because you will find that somewhere it is x square, somewhere it is x to the power 5, somewhere it is x to the power 11, like this. So we are not able to know that what will be the nth term. Okay, because there is no sequence. If sequence is there, x square, x cube, x4, like this, so nth term will be x to the power n. But if sequence is not there, so we are not able to find the nth term. So then there will be a difficulty to use this formula. Okay, so in such cases we can use another method, and that is very easy. You can write, if Taylor series nth term is difficult to find, then singularity nearest to point Z0 gives radius of convergence. Okay, so this method you can utilize there. So what is the meaning of that? Meaning of singularity is what? Suppose I have the series about point Z0. So about point Z0 I have the my function is defined, okay, in some circle. So this is that circle. In that, at every point my series is defined. Understood? So it will converge itself inside some radius. That radius is known as radius of convergence. But it defines this, that inside this only this function is defined, but just outside that or on the circle it cannot be, or it is not defined. So that's why the first singularity means the singularity nearest to point Z0. So nearest to point Z0, where is the singularity I am getting? At this singularity function is not defined. At this singularity function is not defined. So it means there is a break. There is a break that inside this point, inside this radius, function is defined. Function is analytic. But when I am touching this radius, at this function is not defined. So that means your analytic function will break here. Understood? So that point will give you the radius of convergence. Understood? So there is one question also, how we can find that. question is fx is, in place of z he has written fx, so no problem. Fx is 1 upon cos hyperbolic x. So this is a net question. So for this find radius of convergence, and this function about point z0 equal to 0. Okay, so this is the function which is about point z0 equal to 0. So for that, find radius of convergence. And options, one second. Options are infinity, pi by 2, 1. Okay, so what to do means we have to find out the singularity nearest to z equal to 0. Here because series of this cos hyperbolic x, what maximum we can do, this cos hyperbolic x is e to the power x plus e to the power minus x divided by 2. So that we can write. So 2 will go up. It will become e to the power x plus e to the power minus x. Okay. So if I multiply here, because I will not get a perfect series here. Series I will get definitely, but in that series, now that first of all to get the series, that is also a difficult task. And out of that, because there you will find the term x2, x7, x13 like this. Okay, so the terms are like this. So these term, from this term x to the power n I will not get. That is a difficult. So that's why I will apply the method that I have to find out the nearest singularity. So for that, just to get the singularity, I can simplify it. Just multiply it with the e to the power x. So what it will be? 2 e to the power x divided by e to the power 2x and plus e to the power x into e to the power minus x. That will become e to the power 0, and that is 1. Okay. So now this is my new function. Now singularity means I have to find such a point at which this function is not defined. Okay. If I put x equal to 0, so then this function is defined. There is no issue. But at nearest singularity, I want put denominator equal to 0 to find out the singularity. Put denominator equal to 0, e to the power 2x plus 1 equal to 0. This implies e to the power 2x equal to minus 1. Understood? Now for minus 1, the first day of this complex analysis, I told you what we have to write for 1. For 1, we have to write e to the power 2n pi. And for minus 1, what you have to write? E to the power 2n plus 1 pi. I also. Remembering this? So that only I have to write here. So for minus 1, I will write e to the power I 2n plus 1 pi. Okay. So this is the value of e to the power 2x. So value of e to the power x will be how much? e to the power x will be e to the power I 2n plus 1 divided by 2 into pi. This will be the value of okay. Now take antilog on both sides. So what we will get, x will be equal to I 2n plus 1 pi by 2. Okay. So n value can be 0, plus minus 1, plus minus 2, like this. Understood? So if you put n equal to 0, so that will give you the nearest value of singularity. So for n equal to 0, we get nearest singularity. We get singularity nearest to z0 equal to 0, and that singularity is only the radius of convergence. So that x will be, put n equal to 0, so that will be I pi by 2. Okay. So this is your singularity. So from here, x equal to pi by 2 means this is your point z0 equal to 0. First singularity is the at this point. So this point is pi by 2 distance on imaginary axis. If you plot, so at pi by 2 distance on imaginary axis, this point will be there. So pi by 2 is the radius of that. So below that means lesser than pi by 2, my radius of convergence is there. So R value is mod z, that is lesser than pi by 2. Okay. So this one is your answer. So you can note down it. So from here you note down. Note down this. Done?
Yes, sir.
Okay. Okay, so now some more questions we have to do. Suppose there is a question. A function fz equal to 1 upon z into z minus 2 about, means this function is a series which is about z0 equal to 0 point. So this is the origin point only. So about this point in the region z greater than equal to 0 and less than 2. So what is the meaning of this region? This mod z always represent you, see here, z minus z0 is known as radius. This is your radius. This point, and inside the mode z minus z0 is there, so z0 point is known as origin. Understood? So now if z is there, mod z is there, so mod z means if mod z is r written, so here origin is 0. Origin is 0 because z minus 0 it will be, and this is your radius. Okay, here it is shown that mod z is less than 2 and greater than 0. It means what? This is a circle of radius is 2 because mod z is less than 2. So definitely just inside that your radius is there. So just you can draw it that it is 2 only. Okay, and it is starting from 0. So radius is starting from 0 and reaching to value 2. This is the meaning of that. So this is the total region in which my function is defined or function is analytic about this point. So this will give you the series inside the region 0 to 2. Okay. So use this region and write Lorentz series. This is the question. Okay, write Lorentz series and also find out residue, because we know that if we know the residue, so we can do the integration 2 pi I into r. By this formula, Cauchy integral formula, we can find out the integral. So residue is very important. So that's why in every question I am concentrating here to find out the residue also. And what is the residue? You know, the coefficient of 1 upon z minus z0 is known as residue. Okay, so how to solve this problem? By binomial method. You have to check whether we can apply the binomial method or not. So that will be easy. So this I can write it like this: 1 upon z into, here take you can take this 2 common here, or minus 2 you take common. So what it will become now? 1 minus z by 2. Okay, this thing you can take. This is 1 minus 1 upon 2z into, this will become 1 minus z by 2 to the power minus 1. So this is like 1 minus x to the power minus 1. And this series we know. This is the binomial series. I have given you formula also. So 1 minus 2z into, you open up this series. This series is nothing but 1 plus x square plus x cube plus x4. Simple. So 1 plus x, but x is z by 2 plus x square. X square is z square by 4 plus x cube, z cube by 8, and plus dot dot dot. So this is my series. Now multiply this z inside. Okay, you can multiply this z inside, or complete 2z only minus 1 upon 2z you can multiply. First note down up to here.
sir.
Okay. So what it will be the series? So series will become minus 1 upon 2z, and minus z to z will cancel. It will be minus 1 by 4, and then minus z by 8, and minus z square by 16. So this will be the series final. This is the final answer. This is your series. Now what will be the residue? Can anybody tell?
So minus 1 by 2.
Yes, because here 1 by z, because point is about point z equal to 0 they are asking. So about point z 0, so 1 upon z minus z 0 will be 1 upon z only. So coefficient of that is minus 1 by 2. Coefficient of 1 upon z minus z 0 is 0. So it means 1 upon z, and coefficient of that is minus 1 by 2. So like this you will find the residue, and finding the residue is very, very important. Okay. So this is a Laurent series in which this is the principal, this is the non-analytic part only. Otherwise these all are the analytic part. This is the Taylor series, and this portion is the principal part of Laurent series, and it will give you the B1 value. This is also known as B1 value, means coefficient of 1 upon z minus z0. Note down this. Done?
Done, sir.
Okay. Now if same question I give you z0 equal to 2 point, if same question I give you z is equal to 2 point, okay, means your function about z is equal to 0 point, with region also will change. Sorry. The condition only they have changed. In the condition z minus 2 is less than 2. Okay. Use this region and write Laurent series and also find residue. Then this question is similar. Okay. Now this you compare with this. This can be equal also or less than also. There is no problem, because radius is just because just inside that your function is defined. So that's why inside the radius only your function is defined. Okay. So by comparing this, what will be your circle? What will be your radius?
Radius 4.
Oh, no. Radius is same. This is R na. But origin is 2. Understood? On the argand plane, if you make it, this is the real axis, this is the imaginary axis. So this point, this is the origin, this is the 2 point. So that 2 will be considered as origin. And from here, taking the radius 2, you have to draw one circle. So this is this circle. Okay. This is z minus 2 less than equal to 2. You have to compare it z minus z0 equal to r or less than r. There is no issue. So this is the radius. This is the radius na, and this is the point z0, and this point is what? Origin. So origin is at 2. So origin is at 2, and by radius of 2 you make a circle about that. That's it. So this is your circle. Here Z0 is also 2, R is also 2. So now your function fz will be 1 upon z into z minus 2 at z0 equal to 2. This is your function now. Okay. Now for this case, what you need to do, we have to do some replacement. This z minus 2, because when you put z0 equal to 2 now here, so it will become infinite, and that function will not be defined. So what you do here, put z minus 2 equal to t. So then z will be t plus 2. So replace it here. So it will become your function will become, because at the last you can remain it like this only, because at the last we will change over this. T will be again converted to z. But now your function has converted to t. So ft will be 1 upon, in place of z, I am writing t plus 2 into t. Okay. So this t plus 2, here what I can do, I can take 2 common. So it will become 1 upon 2t. It will become 1 plus t by 2. And we can use the binomial. It will become 1 upon 2t into 1 plus t by 2 to the power minus 1. So this is 1 plus x. It will work as x. 1 plus x to the power minus 1. So that series you can open by using the second formula of binomial I wrote yesterday. So it will be 1 upon 2t into, that formula will be 1 minus x. So x is here t by 2, and plus x square. X square will be t square by 4 minus x cube t cube by 8, and plus dot 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 like this. So 1 upon 2t you multiply inside, it will become 1 upon 2t minus t to t will cancel, 1 by 4, and plus t by 8. T to t cancel, so t by 8 now, and minus t square by 16, and plus dot 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 like this. Okay. So here you put here t equal to z minus 2. Okay. So this is like z minus z0. Okay. So my function will become 1 upon 2 z minus 2, and minus 1 by 4, and plus z minus 2 divided by 8 minus z minus 2 whole square divided by 16. So this is also a series. This portion is the analytic portion, and this portion is the principal part. So in the principal part, coefficient of 1 upon z minus z0. So this is z, this is z0 only. Understood? Coefficient of that is 1 by 2. So here you can say residue is b1 is equal to 1 by 2. So this is your residue. So I have simplified it because just single term I can handle. Okay, because I want to make the series in term of z minus 2, because the point z0 is 2. In the last question, I was supposed to make the equation in z minus z0 na, and z0 was 0. So in z only I wanted to make. So there was not any difficulty. But to make the equation in z minus 2, I have to secure it, because z0 is 2. So my my whole series must be in term of z minus 2 only. So I need to secure it. To secure it, just fix it. I have fixed it as t. Now don't disturb the t. Understood? At the last I can write that value and my series will be in term of z minus 2 only. So this series is in term of z minus 2. That's why I have put it equal to t. So whatever you want to secure, that you can convert into some single variable. So this is the method. Okay. So note down it. Done.
Yes, sir.
This is also done now.
Yes, sir.
Okay, next question. You have to practice these questions, okay? And skill you have to increase. Suppose my question is fz equal to sin z divided by z to the power 5. Okay, and question is find residue. Okay, first of all, if I want to ask you what is the pole here and of which order, can anybody tell? Put denominator z to the power 5 equal to 0. So z equal to 0 is pole of order 5. Simple. Okay, but this is not my question. My question is to find out the residue. So for that I have to find out the series. So sin z is z minus z cube by factorial 3 plus z to the power 5 by factorial 5 minus z to the power 7 by factorial 7, like this, and plus dot dot dot. Divide by z to the power 5. So just divide this in every term. So it will become 1 upon z to the power 4. Okay. Now you take, okay, this term will be z square by factorial 3, and from here 1 by factorial 5 and minus, yes Remo,
Z square should be in denominator.
Yes, sir.
1 by Z
For the
square.
second term.
sorry. Okay, so now I want to find out residue. So what is residue here? What is residue? Because 1 by z term is not available. Understood? Here 1 by z term is not available, and coefficient of that will be 0. So residue b1 value will be 0. Simple. Okay. Now you tell me what is the pole sorry, what is the pole and what is the order of that? How to find the pole or singularity and what is the order of that? Okay, by looking the question from here, I told you that z equal to 0 is order 5. But because this is not the final series at the initial looking, this is my now final series. So from here actually I have to confirm whether it is okay or not. And because this is the final series, that will give you the correct answer. So here the maximum power of the pole gives you the order. So here if you put z equal to 0, so this will become infinity. My function will not be analytic. So, but power of z 1 upon z is 4. That is maximum. Okay. So then you can say that here z equal to 0 is pole of order 4. So final equation if you have to take from there. So that will give you the order. Okay. Note down this.
So, which means pole of order 5 is not correct answer, right?
No. I just given you just to understand what is the problem. By looking that, because that is not the final series. So by looking that, you will do mistake. Okay. So that's why I have written that first line. But now I am correcting it because final is this. So from the final series only you have to decide which one is the pole. So this is a Lorentz series, and in the Lorentz series, what is the highest order of the singularity? That will be the pole, the order of that pole. Understood?
Yes, sir.
Done?
Yes, sir.
Yes, sir.
Okay. So actually you need more practice in complex analysis. Then you will come to know that what type of method I have to apply. Again, one question I am giving you, because problem is there when my z0 point is something. If it is 0, there is no problem. We will go simply. But when z0 point is suppose pi by 4 or something, so then the problem comes. So that time you have to secure this value. To secure this value, put it some t or something so that you will not disturb it. And at the final, you will write this, because now I want series in terms of this, because this series is about this point. So once the series is about this point, in the final series, I want all the terms in z minus pi by 4. So that's why I must secure it, and to secure it, just I put it t or x, whatever, so that I will not disturb this thing. Then my final series will be in this only. So this skill you should develop. Okay. So I'm giving you the same question, and same question I have done earlier also. This is the question now. Sin z divided by z minus pi by 4 whole cube. Okay. About, because here if they are not giving you, but still this is the here pole is what? Z equal to pi by 4. So that I need to secure. Okay. And find here, find residue. This is the question. Okay. If fz is given psi z by this, because the series will be about the pole only, if you can find out the pole. So here put denominator equal to 0, So from here, Z equal to pi by 4 is pole. This is the pole. Understood? So this pole, so FZ series must be not in terms of Z, it must be in terms of Z minus pi by 4. So secure it. I'm writing it this line just to so that you can remember. So secure it by replacing Z minus pi by 4 equal to T. So then Ft, then my equation will become Ft sine, it will become T, Z we will convert, this implies Z will be T plus pi by 4, okay. So that will become T plus pi by 4 and divided by T cube. So now you can expand it. So it will become sine T cos pi by 4 plus cos T sin pi by 4 and divided by T cube. Okay, cos pi by 4 1 by root 2 and sine pi by 4, that is also 1 by root 2, that will be common. Then you put the sine series, then you put the cos series, add them and then divide by T cube. So it will be 1 by root 2 into sine series is T minus T cube by factorial 3 plus T to the power 5 by factorial 5 plus dot dot dot. Now cos series plus 1 minus T square by factorial 2 plus T to the power 4 by factorial 4 plus dot dot dot. Okay. Now with that I have to divide it by T cube. Okay, but what is my purpose? My purpose is just to find out the coefficient of residue will be coefficient of 1 upon Z minus pi by 4 because Z0 is pi by 4. It means coefficient of T 1 upon T I want. So coefficient of 1 upon T, from which term I will get 1 upon T? T square by T cube will give me the 1 upon T. Rest all term will not give. So only this term is important for me. Understood? So from this term, what is the answer? 1 by 2 root 2. So that is the residue. With minus sign, no? Minus sign is also there. So minus 1 by 2 root 2 is the residue. You can find out it easily, na? Because I want to just coefficient of 1 by T. Because T is my Z minus pi by 4. So you can find it out directly. Note down this. Hello. Done?
Yes, sir.
Okay. Now Some more methods are there to find out the residue. Methods to find out residue. Number 1, B1 constant
Sir,
of Lorentz series. Yes.
sir, for the above question, what will be the order, sir?
Huh?
For the above question, what will be the order of the poles? For the
Question.
above- Sir, for the above question, what will be the order of the pole?
Order na?
Yes, sir. So it should be like,
No. Order actually I cannot confirm because it is infinite series, na? This is going infinite. This is going in. Okay. Sorry. What is the maximum 1 by term?
sir, it's coming for 1 by t square, sir.
1 by t square is maximum, na? So that will be the order. That will be the order. Okay. Denominator term, what is the maximum? That will be the order. Means from the principal part, highest term you will find out. So B1 constant of Lorentz series. Understood you?
Sir,
Yes.
sir, how 1 by t square, sir, 1 is also there in the course.
I have not checked. I have not checked that. You check it. This is t by t cube now. So it will give you 1 by t square. More than that is there. Sorry, 1 by t cube is also there now. 1 by t cube is also there. Okay. So don't miss that. So you can write it here. Order is 3. Pole is z equal to pi by 4. So pole z equal to pi by 4 is of order 3. Okay. So now it is correct. So, okay. Or you can write, you understand, in Lorentz series na, V1 constant will give you the residue. That is one method. Number second method. For nth order pole. If you find pole of nth order, so then you can find residue by one formula. Limit z tend to z0, means z0 is your nth order pole. 1 upon factorial n minus 1. Means if nth order pole is there, so 1 lesser than that. Understood? And derivative is also 1 lesser than that. Into z minus z0 to the power n fz. That will be the formula if nth order pole is there. So this formula you can utilize. Number third, for simple pole, This is done.
Yes, sir.
Okay. And one more method is yes,
Yes,
yes.
sir.
Last one. Any doubt in this?
No, sir. Yes, I was writing. Done, sir.
Okay. Okay. Number 4 method is also there. That method is of one for a special type. For functions like phi z divided by psi z. Okay. Residue will be limit z tending to z0 phi z divided by psi dash z. Understood? If function is like this, you differentiate the denominator function and in that you put z equal to z0. But provided psi dash z0 must not be equal to 0. Otherwise it will become infinite. Understood? And this method is utilized in complicated equations. Used in complicated equations and transcendental equations. Transcendental equations means containing some hyperbolic part, sine part, cos part, or exponential part. If those type of equations are there, that is known as transcendental equations. Containing hyperbolic, exponential, sine or cos terms. Okay, so this type, for that type we use this. Okay, we will take some example of that. Suppose question number 1, fz is given tan z. Find residue at poles. Okay, so this function fz, tan z, because very difficult to find out, so that I will convert into sin z divided by cos z. Okay, and here to find out the pole, put denominator equal to 0, means cos z equal to 0. So here z will be pi by 2. Cos pi by 2 is 0. So z will be pi by 2 is one pole. Other pole also can be there. 3 pi by 2, 5 pi by 2. So many pole can be there. But just nearest pole I will take, nearest to origin. So that is z equal to pi by 2. That is one pole. On that I will find out the residue. So for that I can apply this method now. So residue will be limit z tending to pi by 2 sin z divided by differentiation of denominator, that will be minus of sin z. Sin z by minus of sin z is minus 1. So that will be the residue. So like this you can find out the residue. So this method is also very good if the denominator and numerator, they are containing some hyperbolic or some exponential or sine or cos term. If they are containing transcendental equation or some complicated equations also, which we cannot solve with earlier methods, so we can apply this method. Okay, Ultimately, we have to find residue, and which one you find easy, that you can apply. Note down this. Done?
Done, sir.
Okay. So I will go little bit harder side now. Next question is fz equal to 10z divided by z square minus 1. Find residue at certain points. This is the question. Okay. Find residue at certain point means so many points can be there to find out the residue. So all residue I have to find. So this again, because tan z I cannot solve. So tan z I have to convert in term of sin z divided by cos z. And this z square minus 1, I can write z minus 1 into z plus 1. So from here, if you put denominator equal to 0, so I will get different poles. Cos z into z minus 1 into z plus 1, they are 0. So separately cos z will be 0. This implies z will be pi by 4. This is one pole only I am taking nearest to z equal to 0 origin. So from here z equal to 1 means if I take z minus 1 equal to 0, this implies z equal to 1. If I take z plus 1 equal to 0, this implies z equal to minus 1. These are the poles. So these are the poles here. So at all these poles, I have to find out the residue. Okay. Z equals
Sir.
yes.
Z equal to pi by 2 only, no? Pi by 4.
Sorry. But remember, here so many poles are there. 3 pi by 2 also, 5 pi by 2 also, all will give me 0. Understood? I am not taking them, but this pole is not simple pole. Don't make mistake, because there are so many poles. So that's why pi by 2 is not a simple pole. But z equal to 1. This is my simple pole. Z equal to minus 1 is also my simple pole. Okay. So for that, I will apply the simple pole method. So for z equal to 1, for z equal to 1 simple pole, what is my method? Residue R1 will be limit z tending to 1. What I should here? Z minus Z0. Z0 is 1. Z minus 1 into Fz. Understood? This is the formula for simple pole. Just now I told you method. Limit z tending to 1, z minus 1 into Fz. Fz is this much. Sin z divided by cos z into z minus 1 into z plus 1. Z minus 1 to z minus 1 cancel. In rest all you put z equal to 1. So it will be sine 1 divided by cos 1 and this will become 2. So answer will be 1 by 2 tan 1. So this is the answer. So this is your residue 1. 1 by 2 tan 1. Note down this.
Yes, sir.
Okay. So at z equal to minus 1, simple pole, residue R2 will be limit z tend to minus 1. So it is z minus z0 means it will become z plus 1 into fz. So put the value limit z tend to minus 1, z plus 1 into fz is sin z divided by cos z into z minus 1 into z plus 1. So this will be cancelled. Now put z equal to minus 1 here and here. So it will become sin minus 1 divided by cos minus 1 and it will be minus 2 into minus 1 minus 1 minus 2. So minus 2 I can keep here. Now sin minus 1 is minus of sin 1. Cos minus 1 is cos 1 only. So it will be minus 2 cos 1. So minus 2 minus cancel. So again the answer is 1 by 2 tan 1. So R2 is also 1 by 2 tan 1. Now coming to next pole. At pole z equal to pi by 2. So at this pole, so residue will be, so then this will become very difficult because here if I put z minus pi by 4 understood, z minus z, like a simple pole, if I put it z minus pi by 2, so that will not be cancelled from here because no term is in z minus pi by 2. So that's why I cannot use this method. So this is very difficult to solve, but fourth method will work here. Understood? You do the differentiation of denominator and put there z equal to pi by 4, then it will work. So what I can use here? So residue R will be limit z tending to pi by 2 phi z divided by psi dash z. So denominator you have to differentiate. And what is denominator here? It will be limit z tending to pi by 2. Phi z is what? Phi z is sin z. Simple. And in denominator what is there? Actually psi z is cos z into z square minus 1. Because from z square minus 1 we have got z plus 1 z minus 1. You can see from here. This is cos z into z square minus 1. So you have to differentiate it. So psi z will be first function as such cos z into differentiation of second is 2z. Now plus second function as such into differentiation of this is minus of sin z. So this will be the psi JEST z. So I can write here twice z into cos z minus z square minus 1 into sin z. In that, in this I have to put z equal to pi by 2. So it will become sin pi by 2 divided by twice z into cos pi by 2 minus z square minus 1 into sin pi by 2. Now sin pi by 2 is 1. This sin pi by 2 is 1. Cos pi by 2 is 0. So how much it will left? 1 by, and this z also I have to put pi by 2 minus of, it will become pi square by 4 minus 1. That's it. Or you can write it 1 minus pi square by 4. So this is the value of R3. So residue 3 is 1 upon 1 minus pi square by 4. You practice these questions. Understood? It will give you very good insight how to solve the problems in the exam. In the exam, whatever the question come now, I will cover all the variety. So just if you practice all these questions, so definitely you will solve the problem in the exam. Okay. So note down this page.
Good, sir.
Note down this also. Next question is fz is e to the power 4z minus 1 divided by cos hyperbolic z minus 2 sin hyperbolic z. Okay, so this is the question. Find out residue at poles. Understood? This is the question. So here to find out the pole, put denominator equal to 0. So your cos hyperbolic z minus 2 sin hyperbolic z will be equal to 0. So this will become 2 sin hyperbolic z will be equal to cos hyperbolic z, or you can write sin hyperbolic z by cos hyperbolic z will be equal to 1 by 2, or you can write the value of this sin hyperbolic z, that can be written as e to the power z minus e to the power minus z divided by 2 divided by cos hyperbolic z can be written e to the power z plus e to the power minus z divided by 2 that will be equal to 1 by 2. This 2 to 2 cancel. So answer is e to the power z minus e to the power minus z divided by e to the power z to the power minus z equal to 1 by 2. Again, it can be more simplified. 2 will be multiplied here. It will become twice into e to the power z e to the power minus z will be equal to e to the power z plus e to the power minus z. Now again, this is 2 e to the power z, this is e to the power z. So only one single will be left. And here this is minus 2 e to the power minus z, and it is plus e to the, so this will come this side and it will become 3 e to the power minus z. First you note down this. Done?
Yes, sir.
Okay. So more simplified, it will be e to the power z minus 3 e to the power minus z equal to 0. Or you can say e to the power z equal to 3 e to the power minus z. Now multiply the whole equation e to the power z, so then it will become 3 only, it will become 2z. E to the power 2z equal to 3. So this is my final thing. Okay. This is the value I can use because my equation can be converted into e to the power term. So that I can use. But if pole has been asked, so for that you need to find the z. So to get the pole, otherwise this equation is sufficient for me. To get pole, again I have to take log of this equation. So then it will become 2z equal to ln 3. So z will be 1 by 2 ln 3. So z equal to 1 by 2 ln 3 is pole. But e to the power 2z equal to 3, that I can use that value. Okay. Because my equation is in cos na, and cos will give you the exponential term, and exponential term value only I can use. But here again, because this equation, this is just to find out the pole and some value which I can use. But this equation is again very difficult to solve. So fourth method we can always apply if it is difficult to solve. Just you need to find out the pole. Pole I have find out, and some value also I have find out. Now I need to this thing will be working as phi z. This thing will be working as psi z. Okay, because in the residue I need psi dash z. In that I will put the value of pole. So this differentiation I need. So residue will be limit, because my question will be converted in terms of exponential term. So exponential value only I will use. E to the power 2z equal to 3. Or if you want e to the power z, so that will be root 3. Whatever you need you can use. This also you can use. Phi z divided by psi dash z. So first I will find psi dash z. What is my psi z? Cos hyperbolic z minus 2 sin hyperbolic z. Psi z is cos hyperbolic z minus sorry. Cos hyperbolic z minus 2 sin hyperbolic z. Okay, so psi dash z will be sin hyperbolic z minus 2 cos hyperbolic z. So that I can write here. So my residue r will become limit e to the power 2z tending to 3 phi z is e to the power 4z minus 1 divided by this one, and this sin hyperbolic z and cos hyperbolic z, because I need in exponential term, so this will be written as e to the power z plus e to the power minus z divided by 2 and minus twice of e to the power z and minus twice of e to the power minus 2z, and divide by 2 here also, divide by 2 here also, that 2 I will multiply here, no issue. Again, now what I can do, because I want to make it e to the power 2z, so e to the power minus z I can take common. Okay, take e to the power minus z common. This is e to the power z minus 2 e to the power z, so it is again minus of e to the power z. And
Sin z sin hyperbolic z. It should be minus.
So sorry here no, yes, so it will be now limit e to the power 2z is 3, so this will become twice into e to the power 4z minus 1 divided by minus of e to the power z and minus of 3 e to the power minus z. Okay, so from here e to the power minus z you take common, and that will go in the numerator, or you can simply say multiply in numerator and denominator by e to the power minus z. So it will become limit e to the power 2z tending to 3, it will become 2 into e to the power z e to the power 4z minus 1 divided by, this will be minus of e to the power 2z, because e to the power z you multiply in numerator and denominator also, and it will be minus 3. Okay, now in place of e to the power z I will write 3, and in place of e to the power z I will write under root 3. So this limit you can put 2 into this value I will write under root 3, this value it is the square of that, so it will become 9 minus 1, so that will become 8 divided by e to the power z is minus 3, so minus 3. So answer is minus of, so it will become minus 6, so 2 cancel, it will be minus 3, so root 3, then it will be 8 by root 3. Okay, so this is a very good question, you must practice it, note down this. These are the difficult questions what can be there. Okay, question will be easy, but if you solve the difficult question, easy will be solved easily. Okay, so you must practice all the difficult question also. Note down. Done?
Done, sir.
Okay. Now we have find out the residue. Understood? So what is our main motto here? Actually, our main motto is not to find out the residue. Our main motto is to find out the integral. Understood? So we are finding out the residue just to find out the integral, because we know the simple formula integral of fz will be 2 pi I into residue. So that's why just we have learned to find out the residue, but ultimately we have to find out the integral. So now second portion of the complex analysis is also finished. Now it is the third part of complex analysis. In the third part, we will learn contour integration. Okay. Now to find out the contour integration, we know the Cauchy integral formula. This is denoted like this: fz dz will be equal to 2 pi I into summation r. This formula we know already. Now here some more fact I will add here. Understood? This symbol is give you the closed integral. You know it. This symbol is the closed integral, and we write C also. So this is a contour. See, this C is for contour. So closed contour integral, like this you can say. Now here, if your contour is clockwise, if your contour is anti-clockwise, the answer will be different. That is first thing. Suppose I am taking case counter clockwise contour. Counter clockwise contour. It means your contour will be going in this way. This arrow will be given at any contour. So this is your contour, arrow is like this. So this is counterclockwise. Suppose this is your point Z0, this is your point Z1, this is your point Z2. So you will find out the residue or at all these points, and then you will find out the integral. Okay. So, but because your contour is counterclockwise, so then your answer will be positive. Fz dz will be plus sign I am giving here. So plus 2 pi I summation r. This will be the formula. So you can remember that it will be answer will be positive. If it is clockwise, yesterday I told you one question of KSAT 2021. There in the question it was written contour is clockwise direction. That's why I have taken minus sign. Okay. So that you must remember. So clockwise contour. So for clockwise contour, you have to take negative sign. So if this is your contour, these are the points. This direction will be like this in clockwise direction for the contour. So here the equation will become fz dz equal to minus of 2 pi I summation r. So this formula you will use. Just in place of plus, you use minus sign. Okay. One more thing. If some point is outside that, Suppose Z1, Z2 are inside and Z3 is outside the contour. So don't take residue for outside point. So you first note down this. So this point is outside point. So you can write here one line. Outside point of the contour, or you can say, because these points are the poles, so in term of pole only we can write this line, or you can say like this: poles outside the contour, poles which are outside the contour, poles of FZ which are outside the contour. Actually, contour is a region where the function is defined. Okay, so for that region only we have to find out the integral of that. So poles of FZ which are outside the contour are not considered. So this thing also you have to remember.
Sir,
Yes.
the third case is from Cauchy integral theorem, sir, or like any other theorem.
Huh?
That's outside pole, sir.
Outside pole?
Yes, sir. That one is not considered following Cauchy integral theorem, right?
Yeah, for Cauchy integral for theorem na, no residue will be added here for the outside pole. No need to find out the residue, because we are finding out the integral inside the contour only. This integral is contour integral. So in whatever the points or poles are inside the contour, for those only we will find out the integral. Okay. What is your doubt? Clear or not?
Yes, sir.
Okay. Note down this. It is done.
Done, sir.
Okay. Ramo, at your place, what time sunset is there?
Around 4:30 to 5, sir.
Okay, okay. Too much early.
Yes, sir. In winter, too much early.
Okay, one more point we can note down here. If some pole is on the line or surface, on the surface of contour, so it means what? It is neither outside nor inside the, that is neither. So we cannot say it that it is outside. We cannot say that it is inside. Okay, so this type of situation will be there. So if some pole is on the surface of contour, that is neither outside nor inside, then its weightage is half. its weightage is half. Okay, so integral will be in place of 2 pi I, just pi I into summation r if so many are there, otherwise single r. Means this is my contour. Suppose this is anti-clockwise because I am taking plus sign, and my pole, this is the pole, z pole. Okay, it is on the line of the contour, so that time you have to take just pi I into r. Understood? So these three things you must remember, otherwise, because one single negative sign or one single half you have not taken, that will give you the wrong marks, and definitely the wrong option will be there. Understood? So that's why you have to practice more here in the complex variable, then only you can solve the problem correctly. Accuracy is must. Okay, so now we will solve some problems, then you will find out how we can do. Question number 1, find integral I twice z minus 1 divided by z square minus z dz. This integral you have to find. It means this is of the form fz dz, and integral fz dz I can find by Cauchy integral formula. There is no issue. So it means here fz is twice z minus 1 divided by z square minus z. So simply poles I have to find out here. It will be 2z minus 1 divided by z into z minus 1. Okay, so what are the poles here? Put denominator equal to 0. So z equal to 0 and 1 are two poles, are two simple poles, because order is 1 for both of them. It is z to the power 1, it is z minus 1 to the power 1, are two simple poles. And by simple pole method we can find out two residue. Okay, so residue r1 will be limit z tend to 0 z into fz. Fz is 2z minus 1 divided by z into z minus 1. So z to z cancel, put z equal to 0 here, it will be minus 1, put z equal to 0, it will be minus 1. So answer is 1. Okay, note down this first. And they have given the contour also in the question. Find integral this over the contour. Suppose this contour is given. This contour is given like this. This is 0.1, this is 0.2, and this is 0.0. So here my poles are z equal to 0 and 1. So both are inside only. Both are inside the contour only. So both are inside the contour only. So for both of them I have to find residue. So residue 2 will be limit z tend to 1, z minus 1 into fz. Fz is 2z minus 1 divided by z into z minus 1. Z minus 1 to z minus 1 cancel. Now put z equal to 1, it will become 2 minus 1, 1. So this is also 1. Okay, note down this. Done.
Done, sir.
Okay, so integral I will be Anjana.
Sorry, sir.
So integral fz dz will become 2 pi I summation r, 2 pi I r1 plus r2, 2 pi I r1 is 1, r2 is 1. So answer is 4 pi I. And you have to check it correctly because your contour is anti-clockwise, so then it is plus. If contour was there now like this, okay, simply just they will change the direction of this arrow, so that you have to take minus. Okay, so note down this. Done now? Okay.
Yes, sir.
So next question is, now next question little bit difficult I am taking, but you practice it, it will give you very good insight. So here find integral I equal to as contour this dz divided by z square minus 1. Okay, over the contour this is the contour given. Okay, now tell me, this contour is clockwise or anti-clockwise? Can anybody tell? Huh? Very difficult question. No answer.
Like for some part, it is coming clockwise. Sir.
Yes.
So,
Actually, this type of question, na, we have to extend our arrow. You follow the arrow only. So here you will put arrow. Again here it will go like this. It will go like this. Now half of that contour, if you see this contour is anti-clockwise. But if you see this contour, this is clockwise. So that's why it has become the two-part question. So this is C1 contour, this is C2 contour. This C1 contour is clockwise. This C2 contour is anti-clockwise. So in such type of question, if 3 contour are there, 4 contour are there, you put 4 contour and separate you do. So in such type of question, your C contour will be converted to C1 and C2. So that's why your integral will be converted to for C1 contour, same thing, and plus for C2 contour also same thing. So that will be the added of this answer. Okay, now so now for this also you have to do, because this is the clockwise contour, and for this also you have to show this is the anti-clockwise or counterclockwise contour. Okay, now for this separately you have to find out the answer. For this separately you have to find out the answer. Now poles are z square minus 1 equal to 0, z minus 1 into z plus 1 equal to 0. This implies z equal to 1 and minus 1 are two simple poles. Okay, now for contour C1. Now for contour C1, tell me, for contour C1, only z equal to minus 1 is inside pole. Only z equal to minus 1 is inside pole. Okay, so only for that I need to find residue. Understood? Because for this contour, z equal to plus 1 is outside pole. So I will not consider that when I am considering the contour 1. So only z equal to minus 1 is inside pole. So discard or neglect z equal to plus 1 pole. Understood? So here residue will be limit z tending to minus 1, z minus z0, z minus 1, so z minus minus 1, that will become z plus 1 into fz. Fz is 1 upon z square minus 1, or that I can write z plus 1 into z minus 1. This you can write now. Here fz is 1 upon z square minus 1, means 1 upon z minus 1 into z plus 1. So that fz I am writing here. So z plus 1 to z plus 1 cancel, put a minus 1, so that will be minus 1 by 2. So that is the residue here. Okay, note down this.
Yes, sir.
Okay, so I want to open the formula also here, because this is clockwise. So what will be answer of this? Answer of this will be 2 pi I, sorry, minus, because that was clockwise. So minus 2 pi I into R1, what is residue here? Plus, for this anti-clockwise, answer will be 2 pi I into R2. So that will be the integral. So just R1 and R2 I am finding out, because I know there only one residue here, one residue here. Okay. For contour C2, only z equal to plus 1 is inside pole. And discard z equal to minus 1, because that is the outside pole. So for contour 2, so for that R2 will be limit z tending to 1, z minus 1 into 1 upon z plus 1 into z minus 1. So this to this cancel, put z equal to 1, it will be 1 by 2. So answer is I will be minus of 2 pi I into minus of 1 by 2 because R1 is minus 1 by 2 plus of 2 pi I into 1 by 2. So you can simplify it. This will be pi I plus pi I. Answer is 2 pi I. So like this you can find. Okay. Note down this. Done? Okay. Now there is one more question, similar type. It was in June 2017, 5 marks question. Okay. Question was, find integral I equal to z into e to the power pi z by 2. I pi z by 2. This is z, this is 2. Okay. Divide by z square minus 1 dz along the closed contour, along the closed contour okay. So this is the closed contour. This arrow they have given, 2 points they have given, this is -1, this is +1. Okay, so this is also the same kind of thing. So this will be given only one arrow, but again here you have to extend it like this, extend it like so many arrows you can make, but you have to go through the same way. Okay, because one line like the current is flowing like this, so this you have to take. So again this complete contour will be divided into two parts, C1 and C2. So this is also same type of question. So here I will be C1 contour z e to the power I pi z by 2 divided by z square minus 1. I can write z minus 1 into z plus 1 dz, and plus for second contour also you need to go through this integral. Okay, now for this again I will tell you the same thing, because this contour C1 contour is clockwise. So here I need to take minus sign, minus of 2 pi I into R1, because there are two poles, z equal to 1, z equal to -1. Out of that, one will be outside, one will be inside, because I am considering at a time only single loop. So for that single, one point is outside. Once when I consider this, for that other pole will be outside, because one by one I am taking now. Plus this is clockwise, C2 is anti-clockwise. For anti-clockwise I need to take plus 2 pi I into R2. Again here R1 and R2 I need to find out, but this will be my final answer. So here 4 contour C1. For contour C1, what to do? Means poles. First of all, poles are z minus 1 into z plus 1 equal to 0. So z equal to 1 minus 1 are 2 poles. Okay, out of that, z equal to minus 1 is only inside pole. Okay, so for that R1 will be limit z tend to minus 1, z tend to minus 1, z plus 1 into fz. Fz means complete. I have to write. Actually, I will take next page. You first note down up to this much. In congested, you will be confused. Note down up to this much. Here, z equal to minus 1 is only inside pole, and discard outside pole z equal to plus 1. Note down this. Done.
Yes, sir.
Okay. So R1 will be limit z tending to minus 1 fz. So fz is z in z minus z0. So z minus z0 is z plus 1 because z0 is minus 1 into fz. Fz is z e to the power I pi z divided by 2 divided by z minus 1 into z plus 1. Z plus 1 to z plus 1 cancel. Now put z equal to minus 1. So it will become minus 2. It will become minus 1. So answer will be minus 1 by minus 2 e to the power minus I pi by 2. So minus to minus cancel. So answer is 1 by 2 e to the power minus I pi by 2. Okay. So this is your R1 value. Now for contour C2, poles are same. Z equal to plus 1 is only pole inside. So for that only I will find R2. Limit Z tending to 1 and Z minus Z0 will be Z minus 1 into Fz e to the power I pi Z by 2 divided by Z minus 1 into Z plus 1. So Z minus 1 cancel. Put Z equal to 1. It will become 2. It will become 1. So answer is 1 by 2 e to the power I pi Z equal to 1 means by 2. So this R2 is this much. So now you can put R1 R2 in the question. So the answer. So integral will be minus 2 pi I into R1. R1 is 1 by 2 e to the power minus I pi by 2 and plus 2 pi I into R2. R2 is 1 by 2 e to the power I pi by 2. So 2 to 2 cancel, 2 to 2 cancel. I will be taken common. Or you can do one thing, because if I take it e to the power I pi by 2 plus e to the power minus I pi by 2 divide by some 2 will be required. So what you do, don't cut it, just take common 2 pi I. Okay, so then it will become
2 pi I. I have taken common, so it will become e to the power I pi by 2 minus e to the power minus I pi by 2 divided by 2. Okay, but here also I want I. Here also I want I. So what I can do? I can multiply by I and I can divide by I. Understood? I can multiply by I, divide by I, so that it will become the formula of sine pi by 2. Understood? So answer will be now this 2 pi I into I, that will become 2 pi I square into sine pi by 2. And value of sine pi by 2 is 1. Value of I square is -1. So answer will be minus 2 pi. And in the option plus 2 pi also is there. Okay. 4 options are 0, 2 pi, minus 2 pi, 4 pi. So this one will be the, this one will be the answer. So if you do one mistake of minus sign, suppose I square also you forgot, so you will get negative marks. Note down this. So very carefully you have to solve these problems. That's why you have to practice more and more. All old year question you practice for that topic, whether it is TIFE, JEST, or means start from NET and GET. If you get the time, enter into JEST and TIFE also. Done?
Yes, sir.
Okay, so this is all for today. You can practice more problems.